the top here. Probably know of for, traverse, and map m for handling effects. Each of these functions does the same thing, but with different argument orderings. Map m has a monad constraint instead of applicative. Okay, we'll use for and traverse, no problem. That's true. Oh, I had my tweets open and not the chat. Sorry about that. Hey, what's up, Commander? How are you today? Cool. Good. I'm warm, like temperature warm. I know that you're not using the temperature version of cool, but I'm gonna take it to the temperature realm. Ah, that's why you're asking about Idris in the Discord, right? Or I assume so. All right, we're gonna start printing everyone's age. Sure. So this is holding with yeah, I mean, when you start like getting used to the Haskell style syntax, you kind of want to give up the C style syntax forever. I feel you there. Wait, why do we do? Why do we do it this way? Shouldn't we do? This? Heck yeah, we should. Gave up C syntax long ago. Yeah, I mean, Rust seems like a very cool language, right? Little tiny bit safer. I've written a little C++ back in the day, but I don't do it much anymore. Oh. I mean, that's fine. A lot of people love Lisps. So, do I not have a name? Oh, we probably changed it to Nombre, right? So there's already a name, so I had to change this one to Nombre, which is just Spanish for name. It's the only other foreign language I have some experience with, so I didn't want to use name prime, so that's what we did. We could have done actor name or something like that, but this is what I did, so we'll just keep it. All right, and then we can just print these things, I guess. So we're gonna say print actors is going to take, or it's just going to return IO list of string. Probably. No, it's not. It's going to return IO unit. And we're going to say traverse of, and then okay, so let's think about this here. We haven't done this in a little while, so I need to just keep working on it. All right, so if we have TV shows and we have a folded, that means we're going to focus on each of these data structures. Then we're going to focus on the actors, which is here. Then we're going to focus on the actual actors, right? The data constructor actors, and then the data constructor for an actor. And then we're going to say show them. Gotta remember what does this look like again? Right, it just takes a function from S to A and applies it on your focus. So that's what that's doing. And our function is put strlen. So that will give us a list of IO units. And then we want to flip that to IO unit, I guess. I think that's right. And you can see this is a little interesting, right? Because you don't actually get the list of unit, I guess. Wouldn't we have IO list of unit in a normal traverse in this situation? I'd have to think about it, but maybe not because it's flattened. I don't know. A to F of R. So it takes the lens. A to F of R. Okay, that's interesting. The type of this here. Okay, yep. A to F of R. The F is IO. Sure. And the question is, does this work? Oops. REPL. Print actor. Sweet. Could do this for other types of effects too. Okay, this is a silly example of using the state effect, but sometimes it's handy to build up a stateful computation from the focuses of a fold. Yeah, this is pretty interesting though. Our modify function will take the state. This is weird. But I suppose, yeah, I mean, it makes sense. I'm surprised it's const plus 1. So it takes an S to S function. Why is it dot const plus 1? Shouldn't it just be modify +1? Exec state. I'm kind of interested by this. So folded modify. What? Huh? Just need to rebuild this and then we'll keep. Do. Do. Import. Okay. So we need an A to F of R function. The type of modify. Type of const. Doesn't matter what. Oh, wait, no. Doesn't matter what B is. Ah. So, okay, so there's an extra TV show in here because of the types. So we want to ignore the input to this A to FR function. We just return the state. I see. Okay. So the types are a little tricky there, but basically there's the A, which is a TV show, and we're basically saying ignore the TV show and just return, just give me an S to S function, which is basically +1. So modify composed with const +1 throws this away and gives you a +1 function to just modify the state. Okay, that makes sense. Took me a second to realize this. All right, so cool. We'll leave that open for now. Getting a bunch of text. Hang on. Just want to make sure they're not important. Nope. Fine. So combining fold results. Think about folds. Sure. I would agree with that. I have that feeling as well. If anyone has questions about monoids and semigroups, just let me know. Oh, fun. Five minutes to monoid. Length of... Okay, we're gonna write a custom monoid, and I assume that we're just gonna have basically a tuple. Some monoid. Mapping each element into some one, sure. Hmm? Mm-hmm. Noise? Noise? I particularly like the name some comes from. I don't really like the age summary. Calc age actor. Calc age. Oh, I see. I'm stupid. This is building a age summary attached to this sum basically. So age. I don't know. We'll call it that for now, I guess. Oh, here I need to write this. Can we do this like... Expected type. Clean. I would have guessed that this works. I already have this. Well, we need a functor to put them in. Duh. So put them into this, I guess. Oh. Trying to use oh, I need to do 3 things. That's the trick. I'm stupid. I'm building a tuple, not a triple. See? Okay. Hmm. I'm dumb. Now I get it. Oh well. That um that builds this inside of a sum. That's not what we want. I just realized that. I should have realized that earlier, but I didn't. Although no, because if you try and yeah, if you try and traverse, you're gonna only get the sum in one place. Doesn't quite work. So, oh well. I was trying to be clever. I failed. Sounds about right. Okay, so anyway, now we have basically this sort of setup where we can get the count and the. Oh, I deleted. That was stupid. Import control lens fold of folded actors, and then reach in folded, and then there a count age. Structure. Cool. What? I must have an issue. Print 56, 48, 57, 56, 50. Ah. Just fix this because if somebody sees this, they might be like, why is this different than the book? 1977. 72. Good. Okay. So Oh, it's the other way. There we go. Easy. Now, what does from integral do? This converts it to anything, doesn't it? In this case, it's int to double. What's this, the constraint on this? What if I just make this a? What's it complain about? So could we just do, and what if we try and just do b here? What does it complain about? Okay, so that's like the most generic version that we can write, which is nice. Not that that really matters that much, but I'm just curious. Fold map of. Oh yeah, that's convenient. Okay. Sure. This one crashes. No, I guess, like, my intuition would say that this shouldn't work, actually. But why? Because this isn't like this is a list of character. But we'll see. View through the fold by using the monoid type class. Normally, view retrieves only one element, but a fold can focus 0 more things. Okay. Sure. Right. Customizing monoidal folds. Singleton. Okay. Our average is actually a bit off though. Oh, I didn't realize that, but I suppose that's true. I mean, is it? Oh, I guess actors, like if you're trying to. Okay. So if we wanted to get. This is interesting, right? Because, like, we're just creating a map singleton. Do we already have map? We do. Okay. I was gonna say maybe it needs to be there. So it's gonna say. Yep. I was gonna say there's not a 2 here, so clearly the way this works is not good. So we need union with. We're gonna say. Let's see if we can figure it out ourselves. So if we want to get actor show map is going to be a map of string, I think, to int. Is going to be fold of I think folded fold map of folded actors folded this is just m, this is m dot map. Yep, so we need to combine these together, so let's look at fold by of. So we have our fold, this, we have a function a to a to a. So we need fold map by of, and we're going to take the fold this is m dot union. I think it's just unions, right? What's the type of unions? It's a foldable of maps. So no. So union with. I'm guessing union with is on keys. This is getting very hard to read, by the way. What's the type of n? It's not. I thought we would need this because we need a function like this. Well, I can't highlight it correctly. R to R to R. We have our fold. We have a function R to R to R. Oh, we need an R. What's we didn't? Oh, we also need an S, which is TV shows. Actual actor to actor. So we need to. Wait, what are we trying to do here? Yeah, we're trying to get at their names, which is nombre. So we need dot. Okay. And then this is m dot empty. And this is just sure. Like that. All right. Thank you, compiler. So listen to your compiler, folks. Actor show map. So And again is in there twice. I guess that's the problem. Okay. Plus empty, sure. We could, yeah, map.empty and empty are the same here because we have a monoid instance. Yeah, totally fine. Okay, cool. So then we get to exercises. Fold action, which is always my favorite part of doing these books because has okay, so do we have any numbers or letters in here? Oh, we have that's right. So we're at Q prime. All right, so we clearly need something that returns a bool. I guess has is all you need. Yeah, so it's has is just like is it, or have we focused on anything? And so an empty list will have nothing, whereas if we have one element, we'll get true. So it's like is our query or fold completely empty? That's that question. R prime. Both Yo Adrian. Adrian is, well, we can say and just for reference, if you appear in the chat, I will use your name in my code. Like that. Okay. So both first, do we just I guess we just do fold of. Yep. This makes this really easy because you don't even have to think about it. You just kind of look at the types and figure them out. S prime each phone ET in a while. And by a while, I mean since I was a kid. And I was scared of it. I remember it pretty explicitly. True. So, some sort of like any of. Oh, because this is just. It's a fold to something to S. LM of. Yeah. Hmm? I could see how this would be really powerful. Like, you could reach into very, very deep structures and worse. This is cool. This is fun. Underscore folded. Gonna. I should have done that differently, but too late now. All right. So we're gonna focus on the elements and return a 2. So 2 is the only even number. So find of is even. Oh, but it's not quite find of. Because, you know, there would be an underscore here. I suppose we could use also minimum. Find min of. Find. Is it just min of? Minimum. There we go. I was thinking it was an even number, but that doesn't work for this particular shape. So the only other option is that that's the minimum. So okay. Oh, right. I need to put the answers in here as well. False. Yo. Ashton. True. Just 2. Okay. All right, so we're focusing on these. We're getting 11. So it's like the last of. Yeah, okay. T prime, U prime, E prime. Just copy. Oh, nice. Pokemon. Everybody likes a good Pokemon. Okay. So we have a lens, function, and what are we gonna get? We're gonna greater than 9, and we're gonna get true. So this is like an A to B function. This is some kind of, but it's not the true, so that doesn't work. Any of, yeah. Or is it supposed to be all of? Are they all? I mean, I guess it's unclear, right? It could be any of or all of. In this particular case. But this is complaining about something. Okay, let's just make this a string. Oh, right. We don't need these brackets. I always do that the first time I do this. And then in theory that should work. We don't have to. We could just specify the type. but you have to specify the type for length, and that's more typing than just saying Bulbasaur is a string. But I guess you could also do all of, I think, reload B prime. No, one of them's less than, so it's not, it is any of. Oh my god. 6. Well, Bulbasaur is only 9 characters, so not greater than 9 characters. W. So this is just 11. It's true. What's the goal here? We're gonna find. Yeah, I guess find of. That would be my guess. Reload W prime. Yeah. Just 22. It's gonna take a long time to like have all of these. It might be nice to just put all of these into one document with return sorted by return types. Sorted by return types and then sorted by complexity. Or arity, I guess. And then that way you could just quickly be like, okay, I haven't. What do I have as arity 3 or something that returns a bool? Because that's what I want. That might be easier. Okay, so one. So blanks. C. Page 108. So 2. Use an action from the list with any fold. My spelling is atrocious. The more I think about my spelling, the sadder I am. Right, so what are these for? That's weird. Oh, spelling. I thought they were the squiggles for HLint. I was like, what could you possibly be telling me, HLint? And it was telling me nothing because there was nothing in the status bar. Anyway. Alright, so we'll maximize this. So we're gonna have X. I'm just gonna copy this. And the answer would be just raise bar. Okay. Actually, let's do it like this. In, out, X prime. Okay, race car. So we can do find of folded race car xin. I was about to do it again. String. This time I need. Well, actually, I can just. In this case, I can say x prime just string. Just. I'm such a doofus. Maybe string. But it's not find of a to bool. Have. It's not lm. Um. What's the type of alum? Always mess this up. A comes first, so raise. Oh, that's fine. It'll just be alum. But it's got to be a foldable, so it's just. There you go. I think that's right. Yeah. Okay. So my in out to y prime is we want to return a bool. We don't want lm of. We probably want to say something about all of them. So we can say all of the fold is going to be each. The function is going to be is or just even, I think. And then the structure will be yn. True. We did it. I think that's the most obvious implementation for these two. Okay. So z in out z So if we did something like find of, yeah, find of would work. So we can just do find of, the fold will just be folded. Then we'll take the I and anything. Oh, wait. No, that won't work. because we need to know all the other ones. Maximum buy of. It's probably maximum buy folded. Should return an ordering. What? Oh, what is it? It's just board? What's, whoops. What's the function? Actually, don't remember. Dumb. A2 ordering. I feel like it's ord compare. Sure. Sure. Okay. Just 3B. Nice. What else could we do? You could say something like, I mean, I would hate it, but you could do something like XY and then view first. Okay, so let's write this in the most, maybe in a slightly stranger way, just for fun. Basically trying to increase the number of lenses. But wait, can it just do this? I don't think it can. Oh, right, this will compile, but it will give you the wrong answer. Wait. Why does this give you the right answer? How does compare work? With tuples, I guess. I'm now officially confused. Word this. I want to see how this is defined because I'm a little confused. Wait, what? first deriving instance? Oh, they're both orderable. Okay, so I sort of maybe keep doing the wrong thing because we changed our workflow a little bit with optics by example. So my muscle memory is kicking in a little bit. Although I guess it doesn't have to. We should just put this over here. Fixate. Okay, there we go. That should be better. I'm very confused. Okay, so the behavior of compare for a tuple is basically if the first thing is less than, then the whole thing's less than. If the first two are equal, then move on to the second pair. So actually, it's perfectly reasonable to just do this. Bear. Okay. So that's just my misunderstanding of how compare works. I guess it has to do that. Like, how else would it do that? Okay. So we got that one. Okay. Now we're on to this one. So we're back around. I'll start using a underscore, I guess. Well, a in. This. A out. 3. I suppose I don't need to write a out, but anyway, I guess I'm keeping it similar. Underscore is gonna be sum of each. I guess we can do both in this case, but each is fine as well. A in. Did I actually write this? Yeah, that's fine. In this particular case, it would be the same if you use both, but it wouldn't work if we had like a triple, and this will work. Right, so each is a little more generic than both, so cool. All right, these are a bit trickier, sure. B in B out. B. So we want to know the word. So, okay. So I have a feeling we want maximum of. But if we do folded active. Hey, how's it going, Darren? How are you? We could make a bot in Haskell at some point, I suppose. That'd be fun. It feels awkward writing a bot in Haskell because Because Soding is writing a bot in Haskell. But, like, we could also write one. There's also Lambda bot. Oh, I don't know if that means anything, but it probably could be fun. A lot of people do that on Twitch, right? They make their own bots as part of their channel. This is bothering me. Yeah, for sure. Exorciswi. I knew what you meant. No worries. Continue working. What we need is a lens that focuses on words. So, is there a words lens? Bet you there is. Click this. See if there's one in lens. I suppose we could make one, but maybe we're not supposed to do that. Because if we had a words lens, it might be easier to. But I mean, what's the terminology here? How's this worded? Oh, I just realized that this is it gives you some direction. Find the first word that's a palindrome. So this shouldn't be equal race car. This should be x equal verse x. There you go. That's better. It's telling me what to do. To be fair, I was after running a fold. Find the sum. I think that this is probably much clearer, right? We don't need to even run a fold. Is sum of not up here? It is. Okay. We'll just use that. Now the real question is, how do we do this one? Without being clever, I suppose. Right? If we take words be in. So that's first. Then we need to do maximum by of. The fold that we want is just folded. And then we need a function that takes x and y and counts their vowels. Is there an is vowel function? Is car vowel. Really? No. To me. Maybe it's not that low alpha. better. Symbol operator. Yeah, put in there. So okay, so we have some accumulator, something goes there. We're gonna start at 0, and that's it. So X is a character. We just want to take X, elem, E, I, O, U, and sum them, I guess. Then we can just say compare. Actually, I think if we just put this in the center, we don't need count vowels X, count Y. Okay. Expected type string to integer. But got bool. Oh, right. If then ac plus 1 else ac. X should be a character. It is. And elem is an A character. String A. I have to fix this. So vowels. String vowels. A, E, I, O, U. And then we can change this to, because we have to fix that to a string, otherwise it's gonna give me the complaints. So I suppose this is not the worst. Let's see if it works. It does. What could be better about this function? Is there like a gotta be a better function than this, I feel like, but I don't know. We want like an A to bool So it's like A, B, A, bool, B. Something like this. Problem is what is the order of these supposed to be? But we might not be able to find anything like that. I mean, this isn't the worst function I've ever written. You know, it's probably fine. Probably fine. Yeah. I mean, sure. Just leave that alone. Okay. C in. Out. A. Underscore. Guess is how I'm doing this. See, the thing is what I don't like about this, for the above solution, is we're really not using a lens to do it. So I really want to use, I want to write a words lens, I think. So words is a lens from string how do you write a setter? I guess you can just return empty list. So lens getter setter where getter equal words setter. This will be also a simple lens. So it's going to take a string s a list of s. It'll just be this, right? Oh, actually, this could be a fold. Maybe. How do we write a fold? Need to think about this. So should be a fold. Right, we gotta remember because what we need is a function. Takes the thing, turns it into perfect. We already have that. It's words. So we can write a fold from string to string. And it will just be folding words. Hell yeah. Okay, cool. That's way better. And then Then we get rid of this, and we can write B in, and then we can write folded dot words fold. Fold words. 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 Be in string. So this we need something else here, I guess. Which I think is the it's fine. Something with an of. List something. So this is our fold. This is structure. So fold did focuses on the characters, and we want to focus the words. That's the trick. Can't do that if we use folded. Like this better. I don't think there's any reason to have like a separate fold words function. So let's just stick that in there. Now, can't think of a cleaner way to write count vowels. So we're just gonna leave it at that. But I think that's a lot better than it was. I don't think there was a sort type function. So I suppose we could folding reverse and then do fold of sum of. I think that just uses, oh, that's got to be a number though. So it's just, wait, yeah, fold of, and then folding reverse dot folded C in, think. So we, okay, so we take Monoid car. We focusing too far. So what I was doing was focusing on characters and trying to combine them. I want to focus on strings and combine them. I think this is right. Yeah. So this folding stuff is it's sometimes tricky to me, which isn't. I mean, it's not surprising. He said it was going to be tricky. So didn't we already do this? I think we already did this. We already did both of these. Oh, but I have to use the functions up there, I guess. Maybe that's the trick. Let's see out. 4, 3, 1. Let's see. Oh. Okay, so let's go look at the functions. So okay, so we can just probably do another fold of and say folded to okay, so get the second one, and then we need to take the 45 and reverse it. So reverse dot show and the structure d in think. And then d, yep, e in out. We're actually doing pretty good with this book. These exercises are quite fun. Mainly because I don't need to do anything practical all the time. I think the PureScript stuff has been very practical. So I'm happy we're doing this. All right, so basically we need to we probably want fold R of, because we can basically accumulate evens. That's probably okay. Fold R of. So the fold that we want is just, oh, right. The focus is just folded. And then the accumulator function is basically N S ACK if even N then ACK else ACK. The accumulator is just an empty list. Structure is EN. Yep. Is that the best one? I don't know. It seems like it, because it's the only thing that returns like an R. We need to return something that's not part of our fold, I guess. I think we need one of these, but our R is a monoid, but it's not the right monoid. I suppose we could do fold map of and make this function such that it returns list of string, and then the list of strings would get combined. I almost said compound. Combined. There we go. I can speak English, I swear. But it's probably better to use fold R of and just use the cons operator, because then there's no plus plus happening. Right? That's usually ideal. Haskell land. So I don't know. Maybe these are okay. I think, is this all of them? Yeah. So now we can like go look at the exercise answers and see what kind of things that he's doing compared to us. All right. So as folded, I think that's the most trivial one. Fold of both. I changed the name because there are people in chat, so I tend to do that. LM of each, perfect. Minimum of folded, great. Last of folded, great. Any of, yep. So that was any of. Find of, cool. Get these. So find of folded, yep, cool. All of each even, nice. Okay, maximum buy of folded, compare. Oh, that's cool. It turns out that the behavior of compare doesn't require you to write compare on first, so it should be fine, I think. And actually, what's the behavior of this? When you have 3 hello, 3 world. Oops. Where does on even come from? I don't know. We'll find it. Data function. Import data function on. Oh, not first. First. All right, so it will always return the last one, I guess. And if we do mine, compare, just compare. I think it'll also return the last one in this case. Let's swap them. Hello. world. So this one, mine returns basically the maximum of the second one if the first ones are equal, and I think his would return hello. And like, you know, what's the behavior you're looking for is basically, you know, it depends. It just says find the pair with the largest integer. Doesn't say anything else. So I guess it's I don't know. Either way, they have to go through the whole list. And it really just depends on the behavior you want on a tie. And in this case, it's a toy example, so it doesn't matter. Either way, interesting. Okay, I'm going to guess. Oh, right. So this is kind of interesting. You don't need to do that either. I guess the point of this was using, I mean, I'm using a fold because I'm still using sum of. I'm just, you know, explicitly using plus and not sum. I think this is okay. Okay, so folding words, we got that right. Oh, that's way better. I mean, way better is arguable, I suppose, but it's certainly easier to read. So I'll just put that in. So the prime. And was this the function I was looking for, actually? What does this function do? It is the function I was looking for. On. Forget about on sometimes. So on B to B to C. So plus A to B to A's. Quite what we want. Right, because what we want is actually this, right? Because our B is our accumulator. So all we want to do is convert this to a B and then apply this function, which is basically just concat. Close to what we want, but not quite. It's almost like when, but not really. Anyway, where'd that go? Actually, right? I did not. Good. So, yeah, I like this quite a bit. We did get the folding words part. But I do like this. I don't know what's better necessarily. Like this might. Are we going through the list twice? I don't think so. Yeah, I don't know. I don't know when this is actually better. If you're not familiar with this on function, I suppose it can be confusing. This is just a plain old lambda. I don't know. Wait, what am I doing here? I didn't want to do anything here. But maybe I did. Let's just keep going. Oh, yeah, and then again, because overloaded strings is a pain. In this document, overloaded strings is a pain. And I'm not really putting the types up here because I'm being lazy, so okay. Yep, so this was one option. I've never even heard of dual before, which is interesting. But this one is fold R of. Yeah. So what I like about my solution. Oh wait, this is a different one. I like this better. This is seems like the right thing to do. I don't know. I don't know what's better. I shouldn't say anything's better or worse. It's just that's something you can do. All right. So fold map of reverse show. This is interesting too. You could to show to reverse. I like that. That's cool. Okay. This one is if even. Yep. So this one is what I was talking about before. This one utilizes the list monoid instance, whereas I'm not using the list monoid. I'm just concatenating things. But we're basically doing the same thing. Cool. Alrighty. So, higher order folds. This is a long chapter, I feel like. Higher order. So, now we're getting to the fun stuff. There's a whole set of optic combinators which alter other optics. I call these sorts of combinators higher order because they accept an optic as an argument and return a new one as a result. You can add a lot of power and flexibility. Nice. So taking and dropping. These are technically traversals, but all traversals are also valid folds. Okay. They have the following pretty scary types. Okay, so we're gonna take an int and this wild thing and return an over. Okay, so the practical signature of these optics. Okay. So it's basically like taking traversals to traversals, lenses to traversals. Mostly taking everything to traversals of some sort. Okay, cool. I don't know that these are that scary to me. The other ones are pretty scary, I suppose. Mm-hmm. So, okay. So what do we want? E F 1, 2, 3, 4. To list of folding taking to folded. Now F is 1, 2. What if there isn't enough? So 1. Oh, okay. That's fine. So dropping 2 would just return empty list. All right. Like there's not enough stuff to drop, so we just kind of don't worry about it. Okay. I say deceptively simple because there's an additional tricky factor we sometimes run into when working with nested folds. Confusion occurs because each additional fold we compose onto our path branches out like a tree. Ah, that's cool. So take two, take two, take two, fold. So what you could do, I suppose, to okay, let's G. So if we had this and we did to list of folded, folded, taking two, folded. Does that compile? Oh, it does not. Interesting. So we've already folded, and then we're focusing. 1, 2, 3. Weird. Okay. Seems like there's probably a way around that, but do each fold value sends values down the stream. Sure. Either one's fine. What if we really wanted the whole fold to select only 2 elements? Oh, okay. So we just flip. We just flip. Oh. 1, 2, 3, 10, 20, 30. Oh, that takes the first 2. That's not right. I see. That was close. That does make sense because it should take these first 2 and then fold them up. So what I wrote makes sense. It was doing what it was supposed to do, but it wasn't doing what I wanted it to do. Okay, so yeah, this makes sense. Okay, I get it. Mm-hmm. Yep, this makes sense now. So taking 3 folded. Ooh, this one's weird. So give me both of them, fold them, and take the first 3. Okay. I don't know that I've ever really used a drop very often, which is fun to use backwards. Ah, so this is kind of like folding reverse. Neat. This is cool. Can we do I want to put these in. Sorry, I should put these in here. H underscore, at least some of them. Specifically this one, maybe? No, these ones. Do. Can you do this? View. So to list of taking while less than 10 folded. Will this go to infinity? Anyone want to take a guess before I do it? I'm concerned it's going to go to infinity. Doesn't. Nice. Thanks, Haskell. Taking while. Cool. Dropping while. Cool. This would be terrible with an infinite list. Don't do that. Okay. So, how much more is there in this chapter? Oh my goodness. A lot more. I'm not going to finish this chapter tonight. Okay. I'm sorry for these horrible names, but like, I can't come up with good names for most of these, so I just kind of start iterating through the alphabet, and we've gone through the alphabet almost 3 times. So sorry. I'm just trying to write something down here. And we have overloaded strings on, so we have this problem quite often where strings just don't play nice. So we need to deal with this. Okay, so what's the goal here? We want to 7. 1, 2, 3, 4, 5, 6, 7. So just dropping a while, I guess. No, just dropping. I think. I hope that doesn't come through the. Oh, what did I just do? Can you hear the music? Anyone's listening? My girlfriend's playing. I don't want this VOD to get muted. A little concerned about that. Oh, she stopped playing it. Oh, she can hear me. Okay, so anyway, J underscore. Looking at you, kid. You got it. Done. Next. K. I think she put on headphones, so now we don't have to worry about it. My precious? That's, I don't understand that one. Folded, taking A. We're probably gonna have to all this. Oh, maybe we don't. We'll see here in a second. Okay, so what's the goal here? So taking 1 words. Oops. Nope. I need a lens, so I have to folding words if I want to get the words. That's the trick. It's a good trick. So this one is just folded, taking 1, folded dot folding words. I think. To be fair, it's kind of the pattern, but sometimes I feel like there's a lot of patterns going on here that I'm just kind of like, I think it should be this. M. My Kuna no. So it's just folded, taking 1, folding words, folded. Pretty sure. Yeah, that's the kind of formatting I like. Here we go. Reload m underscore noise. Okay, so this one easy. N. What we want a taking. So we're gonna say some of no taking to no taking to each. Nice. Noise. Evil. Interesting. So it's like a mirror. Evil. Okay. So we want backwards. So maybe it's just backwards folded. Before I maybe it's just backwards each. I have no idea what this is gonna do. Honestly. Does what I wanted it to do. Okay. So each backwards. I think it makes sense. Just I wasn't expecting it. I wasn't expecting it to be that easy. Sometimes lenses are pretty wild in this case. Okay, so we need this again. But this time, oh, we're adding some stuff here. Backwards each two to reverse. Live snug desserts. That doesn't do anything. Wonder what that does. Okay, we need data car. Data car. Alpha. Q. All right, so it is. How did this work? This really isn't a taking example. Oh, but this is like a. This is like a filter, but we don't technically know about filters, I suppose. And folding with this doesn't mean anything. I just assumed we would do like hmm. Could probably do. Oh, I see. So folding words drop where is alpha. Dropping where. What? While. Yeah, we need the right. Having overloaded strings on has been kind of a huge pain in the butt. Why do I even have overloaded strings on? There's some text in here. How much text is there? Text. That's it. Why is this even here? These could just be strings. Right, then all of these should be fine. Okay, cool. So we gotta figure out what's up with this. 182. Oh. So focus the words, and then for each word, drop them while is folded, and you're gonna fold them back together at the end to end with a string. Okay, cool. And one other thing I'd like to do is get rid of all the string stuff that we can get rid of. So like this is unnecessary. This is now unnecessary. This is unnecessary. That's necessary. This is not. This is not. Necessary. Oops. This. These are also unnecessary. Almost done. Okay, cool. So now we've removed overloaded strings, so we don't need this. We don't have this problem anymore. Is basically what we needed. Okay, what next? Solve the following problems with higher order folds. We're doing a temperature study in a region. We need to run tests on several subsets of the data. Here's the series of daily temperature measurements be given for the clearly in Celsius. And it's cold. Chris is from Canada, so he must have wrote this section in winter. 4, 3, 8, 6. Why am I writing this? I should just copy it. Too late now, though. Okay. First, we're interested in how many days it took until the first thaw. Write an expression which calculates the number of measurements until a temp is above 0. Okay, I need to look at this higher order stuff again. That's just right. Higher order just means this. So we just need right. So if we have this, oh wait, So we can do days since sample. And we really want to know is the count. I forget what the count is, but it's probably something like length of. So we could do oh my gosh. Okay, so this is the length of, and then we can just subtract it from the total length. Oh, I'm stupid. We don't need that. We need taking while less than 0. And then you can just measure the length. I'm smarter than silly. Right? 2. We don't need to subtract or calculate length twice. We can just say we want to know the length of, and then using the lens focus, take the first numbers that are less than 0, and then you'll get the length. So that's the fold we need. Oh, went too far. Okay, next study. We need to know the warmest it got in the first 4 days of the sample. Okay, so, yep. So warmest first 4 days. So we're going to say maximum of taking or folded sample. Got it. Next, write an expression to calculate the temperature on the day after we hit that temperature. You just use the exact temperature of 4 degrees. Use preview, or forget what that one does, so we're gonna have to look it up. It's take a structure and a getter, and I'll give you it's like, I guess it's like preview. Okay. Write an expression to calculate the temperature on the day after. I have no idea what the most convenient way to write this is. So So I think there's first of, and then we can say dropping while what do we say? Another. Oh, I don't need these brackets, I don't think. I do need those brackets. I always use the wrong not operator. What is this parenthesis? Oh no, that is supposed to be there. There we go. I think not equals reads better this way, probably. Maybe. So what does this do? Warmest after. So that is gonna just return 4. Suppose we could do. Doesn't use preview, but like. Can you just say preview? I don't know. I'll look at that answer later. This is more intuitive to me, but it sucks. But maybe you can just do. It's probably the other way, right? It is the other way. Sample. So it's basically first of. Okay. I don't know if there's a better way to write this. It seems to me like you need to first. Like, how else would I get to the 4 without saying dropping while or not equal? And then you need to remove one more. And then apparently this just gets the first of that thing. It's the same as writing first of, I guess. Maybe it's equal to first of. Not sure. Okay. Free. Gonna do of where this is backwards folded. Suppose it can be dot like this. I usually try to like only have one thing to the right of my $sign if possible. It's just a style I like. I don't know if it's a good style, but that's what I do. So 2, okay, cool. And just to make sure it's working, let's change this to a negative sign and see if we get 4. Perfect. Okay. So now we're interested in running statistics on temperature data specifically from the first thaw until the next freeze. Okay. So just going to be dropping while taking a while. First thaw. Sample. Taking while greater than 0. Folded. Dot. Dropping while less than 0. Folded. Think. Maybe it matters. I need parentheses here. Hmm. So if we just do this. This does what we want, right? Well, it does mean right? Oh, I probably have to do it this way. But I assume this still won't compile. Now the question is this the right order? No, it's not. Because you have to drop first. There we go. Silly me. We can't fold it twice here. So we need to combine our optics. We need to build the higher order optic and then apply it. That's the higher order optic we need to build. So this time we're trying to list out all the temperature samples between the first thaw and the final freeze. Okay? The final freeze. Oh, okay. So in between, because I don't have a name for this. So first we want to do this one. And then here we want to do backwards, taking while, no. So this is tricky. All right. So how does backwards? Maybe I just do dropping while less than 0 dot backwards dot folded. Oh, well, shoot. Copy. This can't be folded. I think this needs to be something like each. Or like I don't want to fold here. I want to reverse. So what if I just do can't do folding. Reverse? I don't know what's supposed to go here. This one's pretty tough. So it's like, okay, so what we're gonna do, we're dropping these, then we have this. And we want to reverse them. What if we do use to list of? What if we say dropping while less than 0 folded to list of backwards dropping while less than. Is this a thing you can do? Folded. This shouldn't compile, right? Wait, what? What does this do? What? It's doing something strange. It's doing nothing. We want to do this backward. I mean, we could do this. I think this would work. But what's the right way to do this? Or is there a better way to do this? I don't know. Maybe there isn't. Um, oh, but this is the approximate. Okay, well, the way this is worded is like this, but it doesn't seem to be. We're basically going to take an F and we're just going to do this. Yeah, I mean, I don't really. Is the. Will the type just work like that? I don't think it will. Is he saying implement that? Or is he just saying that it exists? Oh, wait, why did I do that? No. I don't think that this will be happy, but. F. Wait, why is there a second fold? Or the first fold? What's the first fold? I don't know. So A to bool is the dropping while function. So it's like dropping while F folded. Bing. The fold itself is just fold. We just write. That's not a fold. Is that allowed? I don't think it is. I don't know what this is supposed to be. Let's just go look at the answer because I'm very, very tired. We're just about at 3 hours, so I'm very confused by this one. I mean, we made something work, but this can't possibly be the nice way of doing it. Oh. Oh. Wait, no, that's not right. Backwards, dropping while. Backwards, dropping while. I wonder if one's more efficient than. But anyway. Hmm. That won't work. So do 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 do. Hey, hot too. Do we? Backward. Another one. Backward. Dropping while. Hold it. So you can generalize this because this becomes F, and the way backwards works is a little nicer. Because although it's interesting to me that this doesn't work. We had a fold. Can I view a fold or no, can I not? But I would be able to view there. Preview is first of. I don't know. I mean, that definitely works. It does look like there's a. Oh, okay. That was my trimming of function. Um, can't. You could generalize it on F for sure. But dropping while is the problem. I guess. Can you do the following? So. Let's see if adding that works. Oh, it does, seemingly. So trimming of um less than 10. Oh, reload. Trimming of less than 10. And the fold is sample to list of folded. No, because that's just the in folded sample. What? How do I pass it a fold again? You can tell I'm getting sleepy. Okay, I'm too tired to figure this out. This looks awkward. Anyway, so like in this setup, it's a lot easier because you can just do like that. And sure, we even even remove this because it doesn't matter. And then you should be able to do, how do I feed it a fold? I'm now confused again. Where is it? Do. Go here. Oops. Scroll down. Fold. What is sort of the idea? I am confuzzled. Do I need to create a folder? Right? It's just folder, fold something, folding, folding identity, I guess. So trimming of less than 10, folding identity. I mean sample. What is it called? Sample. Okay. This returns list. That's a problem. Need to return a fold. Folding. Yes. Oh. I'm dumb. Oh. Import control lens. I don't understand how to do this. Like, I don't understand a call trimming of right now. Doesn't seem to be working the way I expect it to, or the way I want it to. Right? Because we just want to have a fold, which is like focus all the things, and then trim them. And I would guess that this is what we would want, but it doesn't work. I don't know why. Did I try folding identity here? I think I did. That doesn't work either. So I don't know how you're supposed to use this. How you're supposed to use trimming of. Unless I have a typo. Yeah, I mean, it's hard. It can be hard. I think some of the stuff that we've done is really cool. I just don't understand how this is supposed to work. They really do not. The error messages are brutal. Good question. Look at it. Nonsense? No, we take, well, okay, let's specialize if we can. So trimming of is supposed to take a function that's like, oh, you know what I just realized? Not that that should matter, but maybe it does. I don't know. Oh, okay, let's specialize. So trimming of should take a to bool something in return what? A list of A? And then it just fails miserably. So, I mean, we can just take this type, right? um, I think actually it will. Oh no, it doesn't do that. This compiles. Let's stare at this for a little bit, I suppose. Can I stick fold in there? I don't even really know. Sometimes I'm unclear about how to do that. So it's like here is supposed to be like a fold SA to list of A. But no, the result should be fold SA, I guess. But it's very much unhappy about that. So that's the thing I don't understand is things like this. Like I would guess that that's the right return type for this. But we can also stick fold here and then fold there. Like HLint was saying let's put that there, but I don't think that would help. So I don't know. Well, let's look at his example again. I don't remember if he had the types on there or not. Second. So we're here. I don't think he had the. Oh, he does. So backwards, dropping while predicate, or F, doesn't matter. Well, I do have it written wrong, so that could be something. Hmm. Okay, well, I mean, I guess the real question is, does this work now? So I think it should be like this. But it doesn't work. Backwards. Dropping while. Backwards. Dropping while. The fold. So oh. Anyway, also hi Sandy. Thanks for stopping. Appreciate it. But I'm super confused. Yes, I have to ask Chris about this, but like really doesn't make any sense to me. Also, the types are so confusing. So sample is just like a list of numbers. So like the general idea is, so I wrote this. This is what I ended up writing. So it takes the sample, which is just a list of numbers, and then drops these two off of it. Then we flip it and we basically say again, turn that back to a list. Then we flip this backwards, right? Then we drop these two, and then we flip this backwards. So that's kind of what that does. And Chris ended up writing a slightly cleaner version, I would say. Oh, thank you. Yikes. That makes sense. Oh, I'm tired. As you can see, my brain is melted. And then obviously we should. Okay. Sort of did it. Um, like the stuff I've seen has actually been super cool. I can see how this would be useful for like the data manipulation kind of stuff that I need to do at work. But yeah, it can, these kind of like tricky, I don't know, they feel kind of tricky. So can I not do, can I just do this? Not like that. Like this. It's weird. Basically, like you need all the dollar signs, but like the difference between this and this baffles me. So this folded sample. Oh, well. Okay, that works. Okay, that's better. That makes sense then. That's fine. It's just the you need to compose before you touch, like before you apply to the fold. This makes sense, but very tricky. I hope that this doesn't. This is probably going to get much harder, isn't it? um. So we are here now. Okay. So here we go.